Hello everyone. I want to first start off and thank everybody for viewing today's webinar. I'm Jeff Reed and I'm actually the product specialist for the evaporation segment at BUCHI in the USA. In today's webinar we're going to talk about the Syncore, which is one of our parallel evaporation units here at BUCHI. I'm going to discuss how the Syncore can save you time and money when you're evaporating off samples. So we're going to first start off with a quick overview of what parallel evaporation actually is. From there, we're going to go into the Syncore's capabilities. I'm going to explain how the Syncore works. From there, we'll go over a quick cost-saving analysis when using the Syncore, and I'm going to show you different examples of evaporation rates when the Syncore is used. After this, we'll get into the key features of the Syncore, and from there, we'll get into different components which are required to be used with the Syncore and how these components are considered all-in-one control components. And lastly, we'll get into questions. These questions can be regarding the Syncore or parallel evaporation in general. Anything you have, please just shoot across. At the end of the presentation, I think there's 5 minutes. You can shoot over the questions and we can get them answered. So what is parallel evaporation? So evaporation is when you take a liquid, transform it into a vapor. You do this by introducing energy into a system in a form of heat. Now, from there you take the vapor and transform it back to the liquid. And you do this by, again, applying energy but outside of the system in the form of a coolant. You want the same energy in the system as the same energy out of the system to have an equilibrium evaporation process. Now, all parallel evaporation is you're doing evaporation, but you're doing multiple samples at once. So you're evaporating samples in parallel, which is known as parallel evaporation. So the capabilities of the Syncore. We consider the Syncore a very flexible unit because it's capable of performing 3 different functions on one simple platform. It's capable of complete solvent removal, evaporation to a residual volume, and also it's capable of solid phase extraction. We offer rack ranges, different size racks with different working volumes, starting from 0.5 milliliter up to 500 milliliters. Each rack has a different position. These positions can start from a 4-position rack all the way up to a 96-position rack. So you can see we offer a wide range of racks and modules to actually fit on this Syncore. Why would that be advantageous? Well, the main reason is, let's say today your application requires you to evaporate to dryness with a starting volume of, let's say, 50 milliliters. Well, a year from now, that application, you may come up with a different application which requires you to have a starting volume of, let's say, 100 milliliters, but you have to go to a residual volume. Now, instead of buying a whole nother unit, you can simply switch out your original rack with a new rack. This way, you save a lot of money and you save a lot of lab space. It's very easy to switch out these modules back and forth. A unique thing that the Syncore is capable of is it has a synergy effect with pressurized solvent extraction vessels. What this means is that the vessels you extract into can actually be sent directly onto the Syncore, where then you can do your evaporation process. This actually eliminates the sample transfer. Everybody knows that when you transfer a sample from one vessel to another, there's a good chance you're going to lose analyte. So this synergy effect helps you to actually achieve higher analyte recoveries when you mix pressurized solvent extraction with evaporation. So let's start off with the Syncore platform. The Syncore platform is what produces the heat. And remember, that is the energy into the system what drives the liquid to a vapor form. The platform is capable of reaching temperatures up to 150 degrees Celsius. So if you're working with a high boiling point solvent such as DMF, DMSO, you're still capable of evaporating this off with the Syncore. Also, the Syncore platform is capable of something what we call orbital movement, which is a shaking. What this shaking does, it increases the surface area in each vessel. With this increased surface area, you actually increase your throughput during the evaporation process. This is done by creating a small film throughout the glass vessel. Also, what this orbital movement does, it eliminates bumping. Next, you can see we have the condenser on the right-hand side here. This is what actually condenses the vapors back to the liquid form. So this, remember, this is the energy out of the system in the form of cooling. You can see that the vapors will be condensed into its own single receiving flask. From there, they can be safely disposed of and properly disposed of to your liking. There's a lot of other technologies out there that they tend to have the solvents shoot right through the fume hood. So this instrument is obviously it's much more environmentally friendly, but most importantly, it's safe. It's safe to use because we're actually allowing you to collect the solvent. Lastly, you see there's a heated vacuum cover which seals the glass vessels onto the rack. Now, this heated vacuum cover is capable of reaching temperatures up to 70 degrees Celsius. So what it does, it actually keeps the vapor in vapor form, and it eliminates the chances of that vapor condensing back down to the original glass vessel. Also, a unique thing about this vacuum cover is that each vessel has its own individual seal. Anytime when you're performing anytime you're performing parallel evaporation, cross-contamination is always a concern because one vessel could be directly next to a different vessel. So if bumping occurs, it could jump over to that vessel and contaminate it. So that's why we came up with a system that has its own individual seals and own individual sealing system, its own channel. So if bumping does occur, it won't bump over and splash into another vessel that's right next to it. So the key variable here with the Syncore is pressure. A lot of other technologies out there use nitrogen. The nitrogen is used to help drive off the solvent. We didn't want to go down that path. We wanted to try something else. So we figured if you hook a vacuum pump to the Syncore and produce pressure, what happens is you actually manipulate the boiling point of a solvent by reducing the pressure of the system. There's two things that's very advantageous with this. The first one is obviously you're dramatically increasing the throughput. The second thing is it allows our users to use a more gentle temperature. And this is very important because what if your sample is thermosensitive? You may not be able to set the platform to 70 degrees Celsius, but you won't need to because, again, you're manipulating that solvent's boiling point by reducing the pressure of the system. This is what I find one of the most important things is obviously the money you'll save on not using nitrogen. We did a cost savings analysis with a customer here in the USA. His application required evaporating off 300 milliliters of dichloromethane. This took him approximately 60 minutes, and it required approximately 1,000 liters of nitrogen. Now, the cost of nitrogen will vary between users. It depends what kind of deal you have with your vendor. It can range from starting at 30 cents per liter all the way up to $1.50 per liter. Now, with this calculation, we wanted to be a little more conservative, so we went down to say this customer had a deal where he was getting his nitrogen for 30 cents per liter. And with this application, his lab, he was actually doing this all day. So we considered let's say he's doing it an 8-hour workday. Although there's a lot of times environmental companies, they're working shift work. So it could be a lot more than 8 hours. But again, we want to be conservative. So if you do the calculation, 1,000 liters of nitrogen versus 30 cents per liter of an 8-hour workday doing this application, you're spending $2,400 a day on the upkeep cost of nitrogen. That's why we didn't want to go down that path, and we wanted to use something like pressure, which is free. What generates the pressure is a vacuum pump. So yes, there's an upfront cost of the vacuum pump, but after that, there's no upkeep cost. Like I said earlier, how using pressure speeds up the throughput. Here's an example of different evaporation rates between different samples, and you can see the speed of it is very, very attractive. Start off with hexane. 30 milliliters of hexane is actually evaporated off in 5 minutes. You jump up to the very far end on the right, you see a methanol and H2O mixture, 1-to-1 mixture of 30 milliliters. And you can see that took about 37 minutes. Now you got to consider 15 milliliters of that is H2O. Everybody knows that water is very hard to evaporate off because of hydrogen bonding that's going on. And the boiling point's fairly high. It's at 100 degrees Celsius. And we're still able to do that at a very attractive time. And I'll keep this page up here for just a couple seconds, so if you want to see the other solvents. But again, at the end of this presentation, if anybody wants these slides, I can send them out to you so you can actually just, if you want to show them to other colleagues or so. Okay, so when you're evaporating to a residual volume, what we use is something called a chilled appendage technology. What this chilled appendage technology is you can see in the picture on the right here that this glass vessel at the bottom has an appendage. And the solvent and sample will actually reside in this appendage. And you can see it's in what we call a chilled zone. And it's going to be safely chilled in this chill zone, and this is done through a recirculating chiller. So you have less chances of actually evaporating off your sample because it's safe in this chilled zone. Everything outside of this chilled zone is actually introduced to the platform, which is actually being heated, and everything else would be evaporated off. So if you're concentrating to a residual volume of 1 milliliter, it'll take you right to that chilled zone, and you really have a low chance of losing your sample. For example, let's say you're evaporating off dichloromethane. You have your recirculating chiller set to 5 or 10 degrees Celsius. Well, once it gets down to this mark and you have your gradient program set up, that system's going to aerate itself and take it back to atmospheric pressure, which is roughly 1,000 millibars, depending where you're at in the U.S., what geographical region you're located in. Now, dichloromethane has a boiling point of 40 degrees Celsius. So the chemical property makes it impossible for that to evaporate off when it's in that chilled zone, because remember, that chilled zone is being chilled by a recirculating chiller at 5 degrees Celsius. So therefore, you don't have to be present when the evaporation process is over. If you forget about the evaporation process, that's fine. It's going to stay safe in that appendage. We strayed away from the sensors, so we didn't want to go with an optical sensor, which a lot of technologies use. So we wanted to use the chilled appendage technologies. I ask a lot of customers when I visit their sites, what could they change about their instrument, their parallel evaporation instrument? It is the sensors, because a lot of times sensors fail. It requires a high supervision of the user, also the maintenance and consumable costs. So all that's eliminated with our chilled appendage technology. So I went over a lot of key features with the Syncore so far, but I want to go over a couple more that I really find important. The number one is the ability to control your results. What I mean by this is after your evaporation process, usually you're taking that to an analytical analysis, whether it be GCMS or LCMS. You actually have the ability to control those results. Why is that? It's because you have 3 variables that I mentioned so far: heat, pressure, and coolant temperature that you can actually control yourself. For example, if you want higher throughput, you can use a more aggressive pressure on your vacuum pump. If you want higher analyte recovery, you can use a more gentle pressure with a higher coolant flow through the rack itself. Also, if you notice on the picture on the right, you can see it's a very transparent instrument. It's not in a centrifuge box or a nitrogen blowdown box. Every glass vessel is transparent. A lot of chemists, a lot of users still like to watch the evaporation process take place. If something happens in one of the positions, they can note that and make adjustments for the next run. Also, the material that comes in contact with the vapor, it's very chemical resistant, durable material. There's three main materials that will come in contact with the vapor. It's going to be PTFE, PFA, which is very similar to PTFE, and borosilicate glass. And you can look these materials up and you can see they have a very high compatibility rate with pretty much any solvent out there. Very easy to maintain the Syncore. The only consumable you're talking about on the Syncore is the actual seals of the vessels. These seals are made out of PTFE, so they will last you a long time since it's a very durable material. But if you do have to replace these seals, when you purchase a Syncore, we actually ship you a tool to replace these seals yourself, so it's very easy to maintain. Like I mentioned earlier in the webinar, we have a complete solvent recovery system. So the Syncore is considered a closed system. It's not required to put the Syncore in the fume hood. You can, but a lot of space is limited in customers' fume hoods, so that's fine. The Syncore is not meant to because it actually collects the solvent. And you can see it's a very compact instrument. With its ability to easily switch out racks and not fit in a fume or not having to go in a fume hood, you can see that it can really save you a lot of lab space. Now let's get into the flushback module, which is another key feature of the Syncore. You can see this picture here. The cooling zone, this gray area, which is right between on the top of the glass vessel, that's actually a cooling zone that's going to actually continuously rinse the sides of the glass vessels, of the glass walls. Now, analyte, there's a good chance analyte will stick to the borosilicate glass onto the glass vessel. So if this flushback module wasn't present, what customers will do is they'll take the glass vessel out, squirt it down with additional solvent to rinse down the walls and have it all flow back into the appendage before they pipette it out. Now with the flushback module, it actually automates this process. And it does it with the actual solvent that's being evaporated, so you don't have to use additional solvent. Now, this picture here, you can see how the flushback module really improves recovery rates. You can see the picture on the left is without the flushback module, and the picture on the right is with the flushback module. Now, this is an optional accessory with the Syncore, but we always recommend it because it really does improve recovery rates. And if you go back to how I mentioned how you can control your results with the Syncore, well, this is one of them. For instance, a recirculating chiller is flowing through the rack itself, and it's flowing through the flushback module itself. If you want a very high recovery rate, analyte recovery rate, well, you can use a low temperature on the recirculating chiller so it gives it more of that rinsing effect during the evaporation process, and it'll actually cleanse off the walls more and more. Here's a little table that compares the Syncore with the flushback module versus another technology known as nitrogen blowdown. These two compounds are usually highly tested on an analytical analysis, and you can see naphthalene, there's a 30% difference in recovery rate with this one compound. So you can see that flushback module is very important to have. Again, I'll let you look at this for 2 seconds, and then we'll flip the slide. Like I mentioned earlier in the webinar, the Syncore is capable of solid phase extraction. The SPE module will actually fit right on top of the vessels themselves. This means that all the workup steps that are involved with the solid phase extraction, they're all done without you having to move any of the glass vessels. For instance, you can elute the sample to the glass vessel, you can flow it to the waste vessel, to the drain vessel, and then you can even do your evaporation step without moving any of the glass vessels. All you simply do is turn the valve, which is on each one of those cartridges on top. each one is individually controlled. So if you don't want to use all 12, and you just wanted to use 3 or let's say 6, that's fine. Each one's individually controlled, so you can customize your own flow rate and your own number of samples you want to do at one time. Also, just like the evaporation part, each sample is individually sealed, so there's absolutely no risk of cross-contamination when you're doing solid phase extraction. Now, let's get into the different components that are required to use with the Syncore. There's 3 main components: a vacuum pump, a vacuum controller, and a recirculating chiller. Now, we do offer a cold trap condenser, which requires dry ice, but I just want to introduce, if you decide not to go with the cold trap condenser, I would like to introduce this recirculating chiller, because not everybody has access to dry ice. The unique thing about our recirculating chillers is that it's actually controlled via the vacuum controller. This means you can take that recirculating chiller and put it underneath your bench top out of the way and control the temperature at eye level from the vacuum controller, which is mounted on top of the vacuum pump. Also, since a recirculating chiller is communicating with the vacuum pump and vacuum controller, it actually shuts off when that vacuum pump's not in use after 5 minutes, which will save you a tremendous amount of power. Everybody that's worked with a recirculating chiller or had a recirculating chiller in their lab knows that these devices are left on overnight, and that consumes a lot of power. So it's another way we're trying to become more environmentally friendly. We always suggest going with the V855 vacuum controller with the Syncore. And the reason behind this is because the V855 is capable of step-down pressure gradients. What this means is that you can gradually reduce the pressure of the system. And that's very important when you're dealing with parallel evaporation, mainly because the small surface area that's inside each vessel. That small surface area enhances the chances of that solvent bumping. So it's very important that you have a vacuum controller that can gradually reduce that itself. You don't have to be present to turn the knob. You just program it and walk away. Also, we suggest going with the V700 vacuum pump. This has an ultimate vacuum of 10 millibars, which can suffice most solvents out there. Now, we do offer a stronger vacuum pump. If you have a very high boiling point solvent, we offer a V710, which is capable of a lower pressure. But again, when you're thinking about making a purchase, it's very important to consult your sales representative, consult our technical support department, so we can hear your application and help you get the right components for your application. I already see there's a bunch of questions popping up, so if there's a chance I don't get to every question, here's my contact information. Please email me, call me, just let me know your question. I'll get it answered as soon as possible, because I don't know if I'll be able to get to everyone. But and if anybody has questions, shoot them now, and we'll start off with the first one. Let's see. So this question's asking if there's multiple vacuum controllers involved. You only need one vacuum controller for the system. I'm pretty sure that's. I think what the question's trying to ask is if you can run one vacuum pump or one vacuum controller on multiple systems. And theoretically you can, but it depends on what's set up in your application. Let's say you're going to a residual volume. It's not too wise to set up one vacuum pump and one vacuum controller on both systems, because if one finishes and the other one doesn't, it won't aerate itself. You're still working on the other one. So again, we'll have to see learn more about your application to give you a more thorough answer. Okay, one of the questions is, do we actually supply solid phase extraction cartridges. We do not supply those. We actually have deal with Silicycle that actually supplies these cartridges. The deal is they actually will give you application support and actually help build your application more, and that's who you would actually get the cartridges from. Okay, let's scroll down here to another question. The price of the sync. The price of this unit, it's going to vary. It depends what you get it with. If you decide to go with, let's say, a cold trap condenser, then obviously you won't need a recirculating chiller, which could cost more money. So, I mean, it could vary. It could vary depending on what you end up getting. If you need to get a whole new, the complete Syncore, a vacuum pump, and a vacuum controller, I would say maybe $25,000, but I'm not 100% sure. Plus, there's always deals going on, so you could always contact a sales representative. Okay, and I guess that's the last question there. So if anybody has any more, please just shoot me. My contact information is there. Just let me know. I want to thank everybody again for joining the webinar, and enjoy the rest of your day. Take care.